Here are the video solutions for NCFE Level 2 Functional Skills Maths. This is section A, which is the non-calculator part, and this is September 2020. So let's take a look, first of all, at question number 1, where we need to work out the percentage of the blocks that are red. So we know that there are 276 red blocks, but how many blocks are there in total? Well, what we need to do is just simply add all of these values together. So 75 plus 276 plus 45 plus 50 plus 154. So when I add, I'm always looking for ways that I can easily find a 10. So 5 plus 5 is 10, 6 plus 4 is also 10, so that's 20, 0 carry 2, 10, 14, 21, 28, 29, 30, 0 carry the 3, 3, 4, 5, 6. So we know that 276 out of 600 are red. Now we just need to turn that into a percentage. So 276 out of 600, remember percent means out of 100. So all I need to do is to convert this into an equivalent fraction, which is out of 100. Now what we've done on the bottom, we have divided by 6 to take it to 100. So for the equivalent fraction, we need to divide the top by 6 as well. So what is 276 divided by 6? 2 divided by 6 can't be done, so 0, slide the 2 across. 27 divided by 6 is 4, with a remainder of 3. 36 divided by 6 is 6. So the answer is 46 over 100, so 46%. Okay, for this question we need to work out the probability of him picking 2 small blocks. Well, we can see that in total there are 9 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, but there's only one which is small followed by small, so the answer is 1 out of 9, or 1/9. Okay, so for this question we want the plan view. Now the plan view, that is the view from above. So if we're looking from above, we will see this square here, this square here, this square, and this square. Now, so what we've got here is a row of 4, like so, 1, 2, 3, 4, and the top one here has got 1 coming off it. Now we know that these are cubes with a side length of 1 centimetre. This is 1 centimetre paper, so we simply just need to do a 4 going down, 4 squares going down, so that's nice and easy. Anywhere will do. 1, 2, 3, 4, there we go, and make sure you turn them into squares, and the top one has got 1 coming off to the right. And we are done. Okay, so for this question we know that the model is 5 centimetres high, and in real life it's 20 metres high. So the scale is 5 centimetres equals 20 metres. Now just ignore the units. We can see that to turn a 5 into a 20 we multiply by 5, or a 4 rather, and for 20 to turn it into a 5 we are dividing by 4. So we know that in real life we've got 54 metres. So therefore to turn it into the dimension on the scale, we just need to divide 54 by 4. We can't use a calculator, so we're going to have to use a bus stop. How many 4s go into 5? That's 1 with a remainder of 1. 14 divided by 4 is 4, 8, 12, which is 3 with a remainder of 2. We've run out of digits here, so we need to put in a decimal point, top and bottom, put in a 0, and that remainder of 2 we can stick here. 20 divided by 4 is 5, so the answer is 13.5 centimetres. Okay, let's take a look at E. Noah's making a circular train track, blah blah, and we know that it's got a diameter of 1600, which we can clearly see on the drawing there, and the outside length of each curve section is 157 millimeters, and we want to know how many of these make this track complete. Okay, so this is the circumference of a circle, and the formula for the circumference of a circle is 2 pi r. And we've been told that here pi is 3.14. Now if 1600 millimeters is the diameter, then what that means is the radius is 800. Okay, so we have 2 pi r, so 2 times by 3.14 multiplied by the radius of 800, and 2 times 800 is 1600, so we want to work out 1600 multiplied by 3.14. Okay, so what I would do here is work out, well, what is 16 times by 3.14, and just remember to stick 2 zeros onto the answer. But first of all, I'm going to work out what 16 times 314 is. So 314 multiplied by 16, 6 4s are 24, carry the 2, 1 6 is 6, plus the 2 is 8, 3 6s are 18, put in a 0 because this is the 1 of 10, 1 4 is 4, 1 1 is 1, 1 3 is 3, add these together, 4, 12 carry the 1, 10 carry the 1, 3, 4, 5. So this is 5,024. So therefore 16 times 3.14 is going to be 5024, but with 2 decimal places. So I'm going to put in a decimal point there, and therefore 1600 is this times by 100. So I'm just going to add those 2 decimal places, get rid of those 2 decimal places. So we're back to 5024 again. So it went around the houses there. Probably would have been, well, depends on your level of maths. To me, I know that 1600 times 3.14 is the same as 16 times 314. We're making one number 100 times smaller and the other 100 times bigger, so it will all come out the same. But it doesn't matter how many steps you do, as long as you get to 5024. So the circumference is 5024, and each piece is 157. So what we need to do now is work out, well, how many 157s go into 5024? So 5024 divided by 157. Now, I don't know about you, but I'm not particularly good at my 157 times table. So I am going to do some bus stop division, which is still not going to be very good or very easy. So 0, move the 5 across, 0, move 50 across. So how many 157s go into 502? So if I were you, I would write out the beginning of your 157 times table. So 157, double that, so that is going to be 314. Add on another 157, so 7 plus 4 is 11, carry the 1, 1, 2, so that's a 7. 3 plus 1 is 4. And add on another 157. So I'm kind of doing some column adding, but I'm trying to ignore the 314 here. 7 plus 1 is 8. 5 plus 7 is 12. 2 carry the 1. Plus 4 is 5. 6. Okay, so we wanted to divide 502, so that is 1, 2, 3. And there is a remainder of 502 minus 471. 2 take away 1 is 1. 50 minus 47 is 3. So I'm carrying across 31. So what is 314 divided by 157? Well, that is 2. There we go. So it actually worked out okay. So the answer is 32 curved pieces. Some fairly nasty calculations there, given that you can't use a calculator. Okay, so we're using the scattergram to estimate the price of a set containing 3,500 blocks. So what we need to do first of all is draw in a line of best fit. Now, a line of best fit is a line that's cutting straight through the middle of all of these values, something like that. This would be too high, too steep, this would be too low or not steep enough, so something like that. Of course, people are going to be doing slightly different lines of best fit. It's not the end of the world. I'm sure they're all fine. You could ask 5 students to do this and we could have 5 different lines of best fit, slightly different, but they would all be equally valid perhaps. So all we need to do is from 3,500 go up, draw a straight line up until we hit the line, and at this point here, and then we're just going to go across, and I think I am 2 below 200, so 150, 160, 170, 180 pounds. Now, if you've not got 180, that might be totally fine. You might have 190 or 170, as long as you can show that you know how to do a line of best fit, and from a line of best fit work out a sensible estimate for 3,500, you'll be fine. Okay, so for question 1G, we need to use the median weight to work out an estimate of the number of blocks in the bundle, and the bundle weighs 3,120 grams. So first of all, what is the median weight? Remember that the median is the middle value. So what that means is we need to put these in order. So ascending order is probably easier. 2.7, 2.9, 3.5, 4.5, 7.4 and 9.0. Okay, so to locate the one in the middle, cross off the one on the left and the one on the right. Do that again. And I was hoping to get 1 in the middle, but we've got 2 in the middle, and that's because we have an even number of values. 1, 2, 3, 4, 5, 6. So the median is the halfway point between 3.5 and 4.5, which is therefore 4. If you're struggling to work that out, then just add these two numbers together and divide the answer by 2. So the median weight is 4 grams. Now the total is 3,120, so we're estimating the number of blocks. So if one block weighs 4 and we've got 3,120, we just need to work out how many 4s go into 3,120, and the answer is 780. So we are estimating that there must be 780 blocks. And this is the end of section A.